Africa, Ethiopia, Addis Ababa, 10th of March, 2019.
Ethiopian air flight ET-302 left Bole International Airport on flight to Jomo Kenyatta in Nairobi.
They never make it.
6 minutes after takeoff, the plane nosedives into farmland at over 600 kilometers per hour.
It's a mystery this morning. Why did a new Boeing 737 crash just minutes after taking off from Ethiopia's capital? The airline confirming just a few minutes ago there are no survivors.
Everyone on board, 149 passengers and 8 crew, were killed.
The international response is rapid.
Within days of the Ethiopian Airways crash, every 737 MAX across the entire world is grounded.
Is there something wrong with the plane? Now, using the evidence from the wreckage, official reports, and black box data, we will digitally reconstruct the disaster to understand what goes so tragically wrong. Flight ET-302 is a 737 MAX 8, Boeing's brand new single-aisle plane. How could such a modern aircraft crash?
Immediately, Western sources point the attention at the fact that this is an African airline.
They suggested Captain Yared Getachew didn't have enough experience or he wasn't trained sufficiently to handle this kind of emergency.
No one says it expressly, but there's more than a small undercurrent of racism in what people say. It's a developing world country. It's maybe not quite up to the standard of the Western airlines.
The problem is this argument's been used before, because this isn't the first 737 MAX to crash.
4 months earlier, Lion Air Flight JT-610, another 737 MAX, crashed in very similar circumstances just after takeoff from Jakarta.
As with ET-302, there are Western insinuations that the problem might lie with the airline.
It must have been a maintenance issue. It must have been the crew. It must have been the pilot. Something wrong with the humans, not with the shiny new airplane.
But Flight ET-302 is not a good target for this kind of suggestion.
If you look at Captain Getachew's flying records, he's logged over 8,000 flying hours. He's a very experienced pilot.
On top of that, Ethiopian Airlines have a really strong record for aircraft maintenance, crew training. None of this adds up.
If the crash isn't the result of human error, what does cause it? Key aspects of the Lion Air and Ethiopian Air accidents are strikingly similar.
Both of them crashed just after takeoff, and both nosedived before impact.
But it's the similarities in their flight profiles that really stand out. They go nose up to nose down, up and down like this.
The plane's flying as a roller coaster for 6 terrifying minutes. You have no idea why.
This fits the black box data from Flight ET-302.
2 minutes into flight, the black box shows a sudden nose-down movement. And what's really important about that data is that it shows it was nothing to do with what the captain was doing in the cockpit. In fact, it actually shows him trying to pull back and counter this nosedive.
For the next few minutes, the data shows Captain Getachew battling these sudden nose-down dives. 5 minutes after takeoff, there's a sudden dive from which they are unable to recover.
The black box data basically shows a pilot trying to fly the plane, but the plane trying to crash.
Could the 737 MAX really have crashed itself? The 737 has been around quite a while.
Newest arrival in the Boeing family of airliners, the 737 attracts a crowd.
The 737, the original one, is actually a really old aircraft. It had its first flight in 1967.
This was back in a time when luggage was loaded manually, so you had to be able to access the cargo compartment. It was also a time when people used steps to get into an airplane rather than an air bridge.
The consequence of all this is that the 737 sits close to the ground. 50 years later, that becomes a problem for the MAX.
Boeing's sales pitch to the airlines is that the 737 MAX will be much more fuel efficient. To achieve this, the engines must be significantly fatter and larger than the old ones.
If you put them on the existing 737, they're going to scrape along the tarmac.
737 MAX schematics show that they fix this problem by bringing the new engines forwards and upwards. But that causes a new problem.
Boeing's flight test shows that in certain unusual conditions, the placement of the engines causes the aircraft to tilt its nose up in a way the previous 737 doesn't.
That is not good news.
One of the big selling points for Boeing about the 737 MAX is that they said it was so similar to previous generations of the 737 that pilots didn't need to go through a time-consuming and very expensive recertification process.
The only way this works is if the 737 MAX has the same flight characteristics as the previous model, and it doesn't.
So, Boeing come up with a fix.
Boeing's records show that engineers fix this problem by creating a piece of software that ever so slightly changes the angle on the tail to make it behave like the previous 737.
They call it MCAS, Maneuvering Characteristic Augmentation System. Because Boeing says it's just an update of an existing system on the previous model, called speed trim, the US authority, the FAA, approve it. But engineers then discover that to fly like the older model, they will also need MCAS to step in during takeoff.
Because the plane is flying more slowly, they have to give MCAS more control over the stabilizer. And they do this by increasing the speed at which it changes the position and the amount that it can change.
The previous speed trim system can only make smaller, slower adjustments. MCAS has now evolved into something far more powerful.
This is a system that can take radical degree of control over the aircraft.
Boeing keep this to themselves.
Boeing made these really radical changes to MCAS, and they never informed the FAA what they had done.
They certainly didn't tell the pilots. If you look in the original pilot's manual for the 737 MAX, there's no mention of the MCAS at all.
Could MCAS have killed 346 people? The original MCAS used two completely different kinds of sensor to measure how the plane is flying.
This is good practice for anything that can affect flight safety.
But when MCAS has to be adapted for the low speed of takeoff, one of the sensors proves ineffective. Boeing's solution is simple.
They just deleted it from the system.
MCAS now relies on a single source of data, an angle of attack sensor.
The angle of attack is the angle of the plane relative to the air it's flying in. So it's how much the nose is pointing up or down. The AOA sensor, it's a small device that basically looks like a tiny weather vane that swivels around on the nose of the aircraft.
There is an AOA sensor on each side of the nose. But when the MAX is launched, MCAS uses just one of them. On ET-302, it is reading only the left one.
Flight data shows during the first nose-down event, the left AOA sensor suddenly jumps from 11 degrees to 74 degrees. That's crazy. It suggests the airliner is basically pointing straight up, and no jetliner can fly like that.